Okay, so we're preparing for our first exam here in Stat 330. There are 3 things that I want us to keep in mind as we prepare. First, this exam is a 3-hour live proctored exam. That means that you should have already made a reservation with a live proctor that you're going to walk in, sit down, and take your exam. This exam is not on your computer, it's through a live proctor. Okay? If you haven't made the reservation yet, do it now. Alright, 3 hours probably won't take you 3 hours. However, the idea is that you shouldn't rush. So please make sure that you have reserved 3 hours in your schedule, that you're ready to sit there for 3 hours. Okay? Second, the formula sheet will be provided for you in the exam. It will be the last page of the exam. Okay, so when you get your exam, open it up, get the last page, there's your formula sheet. As you are studying and preparing for this exam, go ahead and make sure you download the formula sheet. It's on Blackboard, that you know what's going to be on there. Okay, don't expect everything to be on there. It's not. So double check what's going to be on there by looking in Blackboard. Okay. All right. Third, bring your calculator. Calculator cannot be connected to the internet. Okay, otherwise, it can be a graphing calculator or it could just be a scientific calculator. If it's a graphing calculator, be prepared that they will delete the memory from it. Actually, you can go ahead and delete the memory from it before you come, but definitely the proctor will also be deleting that memory. So if you have something important in your calculator, make sure that either you're not using that calculator that has something important in it, or that you're somehow okay with them deleting that information. Okay. So as you're studying for the exam, please go through every problem that I've ever given you up until this point. So that includes your supplemental handouts, your homeworks, your quizzes. Go through all of that. Okay. Additionally, in the review, I give good problems from the textbook that you can do. Okay. So those are problems that you may not have seen yet, right? So all the other problems that you have seen already, review that, and then go over and then look at the textbook problems that I have provided. Okay, when I am writing the exam, I look at all of those things, and then I pick my problems from there. So basically everything that you will see on the exam will look like one of those problems, okay? It will look familiar. It will look like it's not going to be an exact copy, but it's very similar to those, okay? So actually now I'm going to go ahead and go to my computer. I'm going to do some of the textbook problems from Module 2. Okay, now Module 1 students tend to do pretty well with, so I'm not going to do any of those textbook problems. But if you're doing those textbook problems from Module 1 and you find you have no idea how to get the answer, or that you have some question that you want to talk about, post that to the discussion board. I'll be more than happy to make a video explanation of those problems as well. So from anything that I do in the my next few videos, where I'm going to do some example problems from the different modules, if you have any questions about any of that, please feel welcome to post that to the discussion board. I'll be more than happy to respond to those questions there. I know that a lot of times I go through these answers relatively quickly, so it's definitely okay to ask questions, more questions, follow-up questions about that. So please feel welcome to do that. Okay, so without further ado, let me go ahead and jump on my computer and we'll do some practice problems from Module 2 from the textbook. So an experiment involves tossing a die, a pair of die. One is green and one is red. Recording the numbers that come up. Okay, so if X equals the number of equals the outcome on the green die, and Y is the outcome on the red die, describe the sample space S. So this is the case where I'm listing out all the elements in a sample space. So first thing that could happen is you get a 1 on the red die. That's a 1. And then a 1 on the green die. Right? So that's one possible outcome. Or we get a 1 and then a 2. Or we get a 1 and a 3. Right? So I could list this all out, but it would take a long time. So I'm just going to go ahead and copy and paste this. I've written it down already. So here we go. This is our sample space. get a 1 on the red, 1 on the green, 1 on the red, 2 on the green, 1 on the red, 3 on the green, etc., right? So there's 36 elements in this sample space, right? And we didn't talk about using the rule method, so don't worry about that. Basically, I want to make sure that we all should know how to list elements of a sample space, though. So given some sort of experiment, we should be able to list out what the sample space is. Okay. So now let's go on to 2.8. So using this sample space, list the elements that correspond to event A, that the sum is greater than 8. Okay? So A is all the events where the sum is greater than 8. So 1 plus 1 is 2. So the sum of that die is, those pair of die is 2, right? So that doesn't work. Sum of this pair of die is 3, right? All the way up to, it only gets at 7, right? Here it equals 8. 2 and 6 equals 8, right? But it says greater than 8. So that doesn't work either. Now 3 and 6, that's 9, right? So that works. Notice that as you go this way across this, the way I've written this out, so like this sums up to 9. This also sums up to 9. This also sums up to 9. And this also sums up to 9. So all of these ones down here, so that's 9, this is 4, and 6 is 10. All these are larger than 8, right? So the sum is all the same as you go diagonally across this sort of table here. So all the events in A are what I've circled here in green. So I'm going to go ahead and paste that. Here they are. All right. So then in part B, list the elements that correspond to event B that a 2 occurs on either die. Okay? So event B would be a 2 occurring on either die. So the first die is a 2 for this entire row. All right? The second die is a 2 for this entire column. When you're listing these out, be careful that you only list 2, 2 once, because right, that's only one outcome. All right, so don't list it twice. So for event B is all of the guys in this row and all the guys in this column, but you only list 2, 2 once. All right, makes sense. Let's go ahead and go on to. I'm gonna skip C, right? Because so let's go ahead and go down to E. How to list the events that correspond to A. Oops, let me go ahead and switch the pen. So A intersection B. All right, so this is, you have to be able to recognize or know how to find the intersection between events. All right, so let's see, what is the intersection for this one? It's going to be anything that's where the same outcome is in both of these, right? So that the outcome is in both A and it's in B. Does that ever happen? No, none of these events in event A, none of these outcomes in event A have a 2, right? But in B, they all have a 2, right? That's how B was defined. So the intersection is null. There's nothing, right? So actually, if I were to ask you then to find the union of A and B, what would you do? So remember, union means that the element, it's in A or it's in B, right? So if you were to do this, then you would need to, if it's in A or B, I'm going to go ahead and type it down for over here first. So it'd be all these guys from A, and then it would be all of these guys from B. Right? So this would be the intersection of A and B. Right? So these are all the events that are either in A or B. Okay? So you should be able to also then, what if someone were to ask you, well, what's the complement of A? Right? So you should be able to answer questions like this. Union, intersection, complement. How do you say, what's the complement? Well, the complement would be everything that's not in A, right? So I'm not going to list it here because it would take a while to write it all out. But it'd be all of these guys. Everyone who's not in A would be an A complement. Right? So you'd list that all out. Right? So you should be able to answer these type of questions for the exam. All right, so let's move on to different counting type problems. A developer of a new subdivision offers prospective home buyers a choice of 4 designs. Okay, so there's 4 different designs that they offer. 3 different heating systems. Okay, a garage or a carport, a patio or a screen porch. How many plans are available for the buyer? All right, so we should be able to recognize this is a fundamental counting problem, right? Because what we have going on is we have one event that has n possible outcomes, another event that has n possible outcomes. So the total number of possible outcomes is m times n, right? But here it's more than just 2. It's more than just m and n, but it's also, so it's 1, 2, 3, 4. There's 4 different things going on here, but it's the same principle. You just multiply all the different number of options that you have. Okay, so we have 4 designs times 3 different heating systems times either a garage or carport times patio or screen porch. That's 2 things, patio or screen porch. So the total number of possible plans from this buyer would be 48 different plans. Okay? All right. So another one. In a regional spelling bee, the 8 finalists consist of 3 boys and 5 girls. Find the number of sample points in the sample space for the number of possible orders at the conclusion of the contest. All right. So let's see. For all 8 finalists, all right. So let's see. If we think about this, we have 8 finalists. So 1, 2, 3, 4, 5, 6, 7, 8. We want to think of all the different ways we can order these finalists. Now, the fact that there was 3 boys and 5 girls, that doesn't matter because they don't ask us about the gender of the finalist here for A and B, right? They don't ask us anything about that. So really all that matters is that there's 8 finalists, and we're trying to rearrange them. So for the first finalist, there are 8 different people that the first finalist could be, right? So there's 8 people there. Second finalist, there's 7 people that they could be, right? Because you can't be both first and second, right? So then there's 6 people for the third place, right? Because you can't be first, second, right? You can't be first and second, so 8 minus 2 is 6, right? There's 5 people for the 4th place, 4 people for 1, 2, 3, 4, 5th place, 6th place, there are 3 people left. 7th place, there are 2 people that could be. And then last place, if all the other ones were chosen, there's only 1 left. Okay? So we multiply all, this is again a fundamental counting problem. And so we multiply all of that out. And let's see, what number do we get? We get 40,320. All right? Now, for part B, it says, what about just for the first 3 positions? So 1, 2, 3. Well, the first position, you have 8 people that could have been. Second position, 7. And third position, 6. All right, so you can multiply that out, and you will get, let's see, 336. Right? You also could have recognized this as a permutation problem for part B. What we basically have going on is we have 8 people that we are permutating into 3 slots. So that would be 8 factorial divided by 8 minus 3 factorial, which is 5 factorial, which is going to be 8 times 7 times 6. So same thing. All right, so here the order does matter. It matters you got first, second, and third, right? Okay. Let's go ahead and go on to the next one. Find the number of ways that 6 teachers can be assigned to 4 sections of an introductory psychology course. Okay, if no teacher is assigned to more than one section. So no teacher is assigned to more than one section, right? So if we have, this is the first section, the second section, the third section, and the fourth section. Now, only one teacher per section, right? So the first section, if we were to fill that one first, there would be 6 possible teachers for that one. But the second section, since the first one's already filled, there's only 5 teachers left over. There's 4 teachers, and there's 3 teachers. Okay? This is another permutation type problem. So basically what you have is you have 6 teachers going into 4 sections. Right? So here we would just go ahead and multiply that across, and we will get 360. Okay, so let's go ahead and do another problem. In how many ways can 3 oaks, 4 pines, and 2 maples be arranged along a property line if one does not distinguish among trees of the same kind? Okay, so that's a very important thing. You're not distinguishing among trees of the same kind. So what we basically have going on is we have 1, 2, 3 oaks, 1, 2, 3, 4 pines, and 1, 2 maples. Okay, and what we want to do is we want to rearrange these. See how many ways we can rearrange these. Where this oak switching with that oak doesn't count as a new rearrangement. Okay, so very common mistake students will make with this is they'll say, oh well, I have 3 oaks times 4 pines times 2 maples. Now this is basically using the fundamental accounting theorem. That is not going to work for this problem because it's not that we're choosing one of these, right? That's what the fundamental accounting theorem would do. If we chose 1 oak, we chose 1 pine, we chose 1 maple, that's not what's happening here, right? Instead, we're actually rearranging all of these guys. We're rearranging these guys. See how many ways we can reorder them. So we're not choosing one of each type. Okay, so choosing, we're rearranging them. So this is going to be a permutation. Now, it's not just a regular permutation though, because if I permutate this oak with that oak, I don't want it to count more than once, right? So this is going to be a permutation of like objects, right? So this is a permutation of like objects. All right. So if you remember the formula for this, that'd be n factorial, the first type, the second type, the number of the third type. Okay. So n would be the total. How many do I have? I have 3 plus 4 plus 2. It's 9. Okay, and then N1 is the number of the first type, so I got 3 of the first type. I got 4 of the second type, and 2 of the last type. All right, if you calculate this out, let's see, I did not write down the answer, so go ahead and calculate this out using your calculator. All right. All right, so let's do one more problem. So here, how many ways are there to select 3 candidates from 8 equally qualified graduates for opening in an accounting firm? Okay, so we want to choose 1, 2, 3 from 8. Now, what's really important here is we do not care the order of these at all. right? They didn't say that, you know, these are coming, you know, the first place candidate, second place candidate, or third place candidate, right? They never said anything like that. So we really, so, you know, if it's like Tom, Mary, and Ellen, that's the same thing as Ellen, Tom, and Mary, right? The order of these three candidates does not matter at all. So I'm not going to be doing the thing where I say, oh, well, there's eight people that could be the first one, 7 people that could be the second one, and 6 people that can be the third one, because that doesn't take into the account that I could just rearrange these and then I get the same thing again. I get the same outcome again. Alright, so instead, because order does not matter here, you can recognize that. You recognize you need to use a combination, right? So what's going on here? I have 8 qualified graduates, and I'm choosing 3. Combination. So we have 8 factorial divided by 3 factorial, 5 factorial. Alright? So you go ahead and calculate this out. You have to memorize this formula for combinations. This is a formula not provided on the formula sheet, but you will be expected to know it. Okay, so calculate this, you should get 56. Alright, so in the next video, I'll do a few example problems from modules 3 and 4.